Okay, so this is another problem on electron configuration of an atom. This time the question is about selenium ion, so symbol Se. So you need to look down in the periodic table and looking at where's the selenium, and there is a selenium right here. So the one way to find out, the easy way to write down is find out the closest noble gases, which is an argon, and then on top of argon you got two S's, and then you have d orbitals, and then you have p orbitals. So this is related to the p orbitals. So specifically, because this is an argon and this is a 1, 2, 3, 4, so that's a 4s, and this is a 3d, and then you are going back to 4p. So therefore, I can write the electron configuration for selenium starting from argon, and then there are 4s, and we are going to use 2 of all the electrons, and 3d, there are 10 of them, and up here you have a 1, 2, 3, 4. So you have 4 electrons in 4p, 4 electrons over there. So what is really going to be determined diamagnetic versus paramagnetic will be whether there's any unpaired electron, and these are all paired, so I don't have to worry about it. The p orbital, you have 3p orbital, the degenerate orbital, and you are going to fill up 1 electron, 2, 3, and 4. So therefore you have a 2 unpaired electron that makes paramagnetic. So therefore, you are looking for argon with complete field, 10 electrons on D, 2 electrons in S, and then 4p. So in 4 and paramagnetic. So the answer for this is E. So this is a number 11. This is number 11, is asking you the vanadium, which is a symbol V. So let's look at where's the vanadium. Yeah, there it is. So it's vanadium. So let's look at write down the vanadium, and like I do, the vanadium, you want to find out where is your nearest noble gas. That's an argon. So vanadium the electron configuration will be argon with, that's 1, 2, 3, 4. So 4s2, and then this will be like 3d orbitals, 3d, and it will be 1, 2, 3. So it will be 3. So now the question here is vanadium 3+, which is losing 3 electrons, and where do they going to lose the electrons? Okay. So this is a case where because this is a transition metal, they're going to lose 4s first. And then you're going to lose the 4s. So after losing 2 electrons in the S4s electron, you still need to lose 1 more. So your answer will be AR. There is nothing in S orbital, there will be 0. And 3 orbital will retain 2. So net loss of the electron is 3 electron loss. So therefore the answer for this will be an A. Okay, this is number 12. This is a sort of the opposite case of the transition metal losing electron, this is a case where halogen wants to acquire electrons, and this is an iodine. And where's the iodine in the periodic table? In this, the 7th column, we call halogen column. So it's right next to it. So iodine-wise, actually, it's much faster for you to find out acquiring one more electron. It will be like xenon, and that's what it looks like. So iodine minus will be same number as a xenon. Okay. So now in terms of the xenon, is the closest one is a krypton. So that will be starting from the krypton. This is a krypton, and you're going to stay with 1, 2, 3, 4, 5. This is a 5s, and this will be 4d, and that is going to be 5p orbital. So once again, this is a 5s, 4d, and the 5p. So 5s, there are 2 electrons can be accommodated, and 4d, there will be 10 electrons can be accommodated, and then the 5p, there will be essentially iodine itself will be 5, but now having one more electron, so it will be 6. So everything is completely filled up, and the correct answer for this will be 4s2 and oh no, not this one. Actually, this one. Sorry about that. Right. So this is a D is the right answer.